Thank you, Bruce. So now it's time for the resolution. So when you start with OSGi development, then typically resolving bundles is something you don't really, it's not the first thing you read about, it's all kind of magic happening behind the scene. And the first time you typically get confronted with the process of resolution is when you found this super awesome library that has like all this nice functionality that you want to use. You drag this library in, put it in your build pod, start developing your bundle, and then you launch everything, and then you get, oh shit, this isn't resolving. So then you're like, what? And typically this is because there's some import to some exotic package that you don't seem to find, and you're like, yeah, what am I doing wrong? Must be the system. So that's basically why I'm doing this talk, to kind of give you some of the basics of what is this resolution process and how can you deal with it, what can you do if you face these kind of things. So to start off, let me just ask you guys a question. So when do you guys resolve? So who here in the room has like a runtime framework, everything is running, and they then feel brave enough to just install a bundle in there and at runtime make it resolve? Who does this? Yeah, some of the experts in the backseat rows. And who of you has like this this folder filled with jar files, and then when you hit launch, you go through seeking all these files and you just install them and you start them and hope everything goes right. So basically at launch time, you just hope that everything runs. Who does that? Okay, Bruce over there. And then finally, who are the guys that at development time hit resolve all the time to check whether everything's still working? Yeah, okay. And that's basically also my preferred one. So at development time, check out regularly, am I still doing stuff correctly? Is this thing still resolving? And that can get away a lot of the pains of resolving, because you know at the very first step already, what I'm starting to do now, I must make sure it resolves first before I do any more work and I screw up in the end. So let's start off with some of the basics of resolving. So basically, if you look at OSGi, you have OSGi bundles, but the actual first sentences in OSGi are actually the packages. So inside your bundle, you might have export packages, which are the packages that you want to share with the world. Everybody can use them. These are typically your API. And then inside your bundle, you also have some private packages that you don't want to share at all. And these typically implement your API. And third, you also have your import packages, which are packages that you depend on for your implementation to work. So if you want to work with this bundle, you need to figure out where you can get these packages from. And that's basically what happens in the framework when you resolve. So if you drop your bundle in the framework, there is a resolver, and that will then check, this bundle needs import package foo.bar.util. Is this installed in the framework? Nope. So you're out of luck. Your resolution will blow up. If you, however, have already a bundle installed, which is foo.bar.util, which has this package, then your OSGi framework say, hey, good, you have the correct export package, the correct version, so you can match this import, so everything will work fine. So that's basically how the mechanism of resolving works in OSGi. Now, of course, the cool part of this resolver is that you can also use it outside of your OSGi framework. So then basically you have a resolver, and you have a repository of all the nice libraries that you ever found on the internet you want to use, and you put these in a repository. And then you can also ask the resolver, what if I need foo.bar version 1.0.0? Which are the bundles I need to resolve that? And then it will also come up with a solution and say, okay, you'll need the implementation bundle, but you also need this utility bundle. And it will also match the versions. So you can basically already query before anything is deployed inside the framework. Suppose I want to have this bundle, what else do I need to make it resolve? And with recent tooling in OSGi, especially with BND tools, it becomes very easy to do so. So let me go to a quick example in Eclipse, where you basically have two bundles. I have a utility bundle that has a very awesome utility function that concatenates two strings, or multiple strings. And I have a greeter function that says hello to the world, of course. every demo needs a hello world. So the thing is, this greeter bundle basically requires my utility bundle. So I can have a BND run file, which is basically a launch configuration, where you can specify the framework you want to launch, your runtime execution environment, and also the bundles that you want to run. For example, I want to run my greeter. So if I launch this, bam, it blows up and it says, yeah, of course this isn't working because you need utility bundle. So what you can do is manually add this utility bundle to your run bundles list. But what's even more cool is instead of specifying your run bundles, you just specify, I just want this greeter bundle to resolve. So you add it to your requirements, and then you hit resolve. And then the system will automatically say, yeah, probably you'll need utility bundle as well before this thing can work. So if you now launch it, it will run fine. Okay, cool. So now we're able to resolve our packages. But there's more in OSGi than packages. Of course, you all think about services now. OSGi is all about packet bundles and services. But before we go to services, we'll talk about another concept that I think is maybe even more important in OSGi, which is the extender model. And what is an extender in OSGi? Basically, it's a bundle that looks to all the other bundles that come into the framework and can do something on behalf of that bundle. So for example, most of you will know declarator services, and that's basically an extender bundle that scans for every bundle whether there is this service component description. So if it has this XML, it will parse this XML and then, for example, register some services on behalf of the foo.bar bundle. More recently, you have the configurator bundle that also scans your bundles for any configuration JSON in your bundle. And if it has some configuration, it will apply it to config admin. So these are very cool bundles that do stuff before you, and this otherwise is logic that you have to do in every bundle, but now you have somebody that does it for you, which is really handy. Of course, the thing is, if you now deploy your foo.bar bundle, you really want this configurator bundle to be there, because else your configuration is not applied, nothing is being done. And you don't enforce this with a package. You don't have a package import felix.configurator or something. So we have the resolution step for import package, export package, but this is not enough. We need more than that. And that's basically requirements and capabilities. So that's kind of an abstraction of import and export package, where you have a requirement which is just something that the bundle needs, and is being defined by a namespace and some directives. And on the other hand, you have capabilities, which is what the bundle provides, what the bundle has to offer. And you also define it with a namespace and some attributes. So for example, if you look at the import and export package, this translates to requirements of the namespace osgi.wiring.package, and the attribute is the package name and its version, and the requirement can be a filter string saying which package you need and which version range you want. And similarly, you can also specify, I need a certain extender. So for example, I need the osgi.component extender. Or you can have Felix SER that says, I am the extender, so if you want an extender, pick me. And this basically allows you to use the same resolvers framework to also get in these kind of extender bundles. So if we go back, so I have some extra bundles now. So now basically I made a component out of my greeter implementation. So you see, I use the DS annotations, and basically because of that, in my manifest, it not only has the service component XML, but it also says I require this extender. So if we now go back to our launch file, And we add our greeter bundle again. There we go, and we hit resolve. Now it says, hey, you also might be interested in adding the declarative services implementation, because else your bundle won't do anything. Okay. So now that you know about requirements and capabilities, let's move on to the service concept. So in OSGi, if you write a service, you typically start with an API. You have an API bundle that exports the API, and then you can use this bundle to put on the build path wherever you want to use this API. And then you have another bundle, the implementation, that basically implements the API and exposes this as a service. And then, of course, you need a consumer that also imports this API and that can then consume the service. But here again, if you want to resolve this based on the packages, if you want to resolve your consumer purely based on the package, you just need the API and then you can resolve the packages. So again, if you want to resolve this, typically you also want an implementation of your service. And that's why you can also have a capability for your services. So now your implementation provides this OSGi.service capability that specifies the name of the service. And then you can also have a require capability that says, I need a service with this object class. And also look at the very bottom that this require capability has an effective statement. And effective means I provide this capability, but at a certain moment of time, this capability becomes effective. And the default effectiveness is at resolve time. If you have a package, whenever your bundle resolves, then it has the capability of offering that package. With a service, however, this is slightly different, because if you install your bundle, the service isn't necessarily there yet. The service is only there when your bundle becomes active. And that's specified by the effective is active statement. And this becomes important if you want to use the BND resolver to assemble your application. So let's now do that, try to resolve a service. So besides my greeter, that's now a service, I also have a GoGo shell bundle. And this is basically a consumer of my service. So this will reference the greeter service and then offer a shell command to actually consume it. So if you now go to our launch file, you see I require my command line bundle to be resolved, but also I set resolved of the effective is active. And this ensures that we also take into account that I want the service implementation. So if we now resolve, you can see that I get my greeter bundle, I get my consumer bundle, I get the utility bundle, and I also get the declarative services implementation and also the GoGo shell implementation. So let's run this. So greet test, here we go, hello test. So this works. So keep in mind that I put this resolve is effective here. So if we don't put this on active and we hit resolve, then exactly what you get is you just need the API. So bear in mind, if you want to assemble an application and you want to resolve it with the BND resolver, this one line is pretty crucial. It took me a long time before I figured that one out. Okay. So now we know how the resolvement works, what requirements and capabilities are. How can we create our own capabilities and requirements? And well, that's super easy. On the one hand, you could naively just write them into your bundle manifest, but that's not a recommended way to do it. But what we can also do is use bundle annotations, which were added in the spec since R7. So basically, you can add a capability annotation on one of your class files in the bundle, and that basically specifies the capability with your namespace and whatever attributes you want to add to it. And similarly, you can create a net requirement annotation with your namespace and some filter. And then basically, automatically, BND will add those correctly formatted require capability and provide capability strings into your manifest. And you can also use them to resolve your application. So let's go to an example from that. So I have some extra projects now. There we go. So now I added another implementation of my greeter, which is the fancy greeter. And I basically added a custom capability saying, I add the greeter format capability, and I said this is the fancy one. And then in my commands bundle, I can basically say, I don't just want any greeter, I also want the fancy one. So you add requirements with the same namespace, and you say it's fancy. So if you now hit resolve again, it will now resolve to the fancy greeter. And we can run it. Hey, that's more fancy. What you can also do, if you don't like to write all these namespace and name and attributes, if you don't want all your consumers to remember what's the correct namespace and what's all the attributes, you can also use this string on another annotation. And then you can use, for example, require fancy. So now you basically create your custom annotation. And if you look at what's in there, you basically use the requirement annotation on an annotation. And this way, for your consumers, it becomes very easy to add a requirement on something you really want to have accessible right away. And then you can also resolve it the very same way. So if we hit resolve, it will again have the fancy greeter. And if we look at the generated bundle here, you can see that now it requires the capability of the greeter being fancy. So cool. But now what about the runtime stuff? When I asked in the very beginning who resolves stuff at runtime, it was only the few experts in the back that raised their hands, so this must be next level shit. So let's try to look at that. So one of the cool things is that the OSGi framework's resolver, it's not only internally used in the OSGi framework, it's also exposed as a service, and anyone can use it, also you can. And I talked about these repositories, and also these you can make available at runtime as a service. There's a repository service for that. And if you combine those two, it's basically fairly easy to write your own deployment agent that asks for the resolver, I want this bundle, resolve it for me, and by the way, here's this additional repository of stuff you might need in order to get it working. And by combining those, you can basically do all the resolving for you. And if you now install a bundle at runtime, it will also search for the dependencies in the repository. So how does this resolver service look like? Basically, there's only one method that does the heavy lifting, which is, strangely enough, the resolve method. And this thing has one argument, which is the resolve context. So what's inside the resolve context? Well, a bunch of methods, but only two of them are really important. The first one is get mandatory resources. So here you specify basically what are the resources you want to resolve. For example, you want foo.bar version 1.0. This is the resource I want to resolve. And the second method is find providers for a certain requirement. And this is basically where you implement, like, if I have a requirement, how can you find, which are the sources that you can go through to find anything resolving this capability? And so typically there you can go through your repositories, or you can have a custom index of capabilities, or you can list the capabilities of your current framework. So let's go to an example of resolving at runtime. And I again need to import an additional project. So now I basically created my own installation agent that has a reference to the resolver and has a reference to a list of repositories that are available in my system. And I provide one command install with a bundle ID and a version. And then basically what I do is I create first a requirement based on this ID and version. And then I create a resolve context with which I call resolver. So what's in this resolve context? Let me just make it bigger. So basically I create this resolve context out of a requirement. And this requirement basically states, I need an artifact with this bundle ID and this version. So first I will find this resource in my space, because if you cannot really find the first bundle you want to install, yeah, then you cannot install anything. And this I put into the mandatory resources. And then to find providers, I do two things. First, I add all the capabilities from any bundle that's already in the framework. So here I just run through all the bundles in my framework and I add all their capabilities there, because if they're already in the framework, there's no need to install another bundle. And then I also search for capabilities that are available in any of my repositories that I have at runtime. And that's basically it. So then we resolve it, and then I go to the set of resources that my resolver says, this is the set you need to resolve this thing. I run over them, and some bundles will already be in the framework, and others will come from the repository. So that's the check here. If it comes from my repository, I will probably still have to install it and start it. And that's then what I do. So now I start the OSGi framework without the greeter. This does nothing. But with my installation agent there. And if I say example install resolution example, you see it not just installs the bundle I wanted, but also all the dependencies I need that are inside my repository. But also note that it's not installing the GoGo shell or the Felix DS bundle, because these were already inside the framework. So basically your agent, by combining your repositories and your current framework's capabilities, is smart enough to just decide which are the bundles you need. And now it works again. So, to conclude, resolving is actually a gain, it's not a pain. It's really a feature from OSGi that can help you better and more flexible assemble an application. But the trick is to resolve early and often. And one of the most important things that I less stressed upon during the talk, but it's really important, is that all the mess comes from your repository. If you have a messy repository with all loads of crappy bundles, then resolving will be hell. But if you really curate your repositories and you quality check what goes in, then resolving will be a breeze and everything will go fine. And really use the tooling, and especially the BND tools is very, very good for this purpose. Use the tooling, curate your repositories, and life will be much more brighter than before. Thank you. Yes, question? Well, typically, what I do is at the moment that you want to drag in an additional dependency because it seems like legit to use it, that's the moment that you have to kind of go through the resolve step and basically go back to the very first exception that I showed, where you see whenever I want to resolve this with my current repository, it still doesn't work because you're missing these packages. And then you go to the sources like Maven Central, you search for these packages, and you look for the most sane bundle that offers you. And that's kind of a tedious job to do, but if you do it at that certain point in time, you make sure you have your dependencies inside your repository, and then you lock down your repository again. That's typically the approach I take. But still, there's no silver bullet, and there's a lot of libraries out there that just don't have the right metadata or have some fishy imports or whatever. So that's always a pain, but yeah. Any other questions? There are also some projects out there, like for example En route, that have like a very nice curated repository to start from, with like lots of often used bundles and RIs from different specifications. So that's probably a good start for a repository. Yeah. 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 That's actually a very good question, because even if you want to resolve at a development time, you're not really sure about the platform you're going to deploy to. So this native aspect is something you only know really at runtime. But the nice part from OSGi is that you also have the native capability. So every framework can say, I have a native capability with the architecture that I'm on, and your bundles can then have a requirement on, for example, if I include some native code that's compiled for ARM, then it will have a requirement on the architecture being ARM, and it will only resolve when your runtime has this capability. So even then you can use this to gracefully select the right bundle or fragment or whatever you want. Okay, no more questions. Thank you very much.